Hi, I am Jia Yuan. Today, with my partner Ze Chen, we are going to show you how to use the interesting radiometric dating method to predict the age of our solar system and the universe. The Big Bang theory is the most convincing theory explaining how our universe is formed. As shown in the picture, we can see that all sorts of reaction happens. And finally, supernova generates massive elements, including radioactive ones such as uranium. And we are able to use them to date the age of our solar system and the universe. Let's have a brief understanding of the radiometric dating method first. It is based on the radioactivity of certain substances. Those substances will transit into lower mass atoms and leads to the decrease in their own mass. The decay rate is proportional to the abundance. Then we can have this equation.
So we take a look at this equation, and this is what we learned from differential equation. It is a first order linear ODE, and n represent the numbers of atoms in radioactive sample at time t, and lambda is the decay constant regarding to its half-life. But how to solve the equation is divided n on both sides and take integration on both sides, and finally we have n equals to n0 times e to the power of minus lambda t. And n0 is the substance concentration at times equals to 0. And we need to get lambda. The constant lambda is regarding to the half-life, and we know n tau divided by n0 equals to 1 divided by 2 because it is the half-life of the original. And this is how we got lambda. And by knowing all the equation, now how can we find the age of our solar system? First, we need to find the suitable elements, and we are picking uranium because it is generated by the supernova nearby. And by determining the supernova's age, we can determine the upper bound of the age of our solar system. And we're using two isotopes of the uranium, isotopes uranium-238 and uranium-235. The isotopic ratio measured at present is 137.8. And from nuclear synthesis theory, we have its original abundance at the supernova as 1 because they are close to each other in the atomic number. Then we bring back the lambda to the equation, and we are calculated that t is around 5.89 billion years old. So we can predict our solar system is at most 5.89 billion years old.
Similarly, we use the same method to calculate the age of the oldest stars to predict the age of the universe. But uranium-235 is no longer useful. Its short half-life makes it hard to detect. So instead, we use stable elements, osmium and uranium, as substitutes.
Then we got the ratio of those two stable elements to uranium-238 here at present, and at time 0 we got a equation of the uranium-238 to those two stable elements here, but they are not equals to 1 because osmium and uranium are now close to uranium in the atomic numbers. And we have the lambda. And since osmium and uranium does not decay and they are stable, so their original abundance at the Big Bang and at present should be the same. By that, we can use this equation and finally got T for uranium divided by the osmium ratio. We have our T equals to 13.6 billion years old. And for the uranium ratio, we have 11.8 billion years old. Then we take the average, what we calculated. Add them together and divide by 2. We have it 12.7 billion years old. This is probably the earliest supernova happened. And we know supernova happened after the early supernova happened after the Big Bang. Then take the difference to be 0.3 between that, and our universe is predicted to be 13 billion years old. Thanks for watching.